How's it going? Okay, is it working? Perfect. How's it going? You're doing great? Perfect. Okay, so what we're going to do today is talk a little bit about smart accounts in the context of OpenZeppelin contracts. This has been a really requested feature that we had been working on for quite a while, and we have a couple of things to discuss on regarding this. So let's get into it. All right, so this is the agenda. First, we're going to start with a little bit of background. Where are we starting from this work? Also, how to do account abstraction, like on a general perspective, just as a quick recap of what account abstraction means. Then we're going to custom signature algorithms, which is one of the main topics and is the thing that is like the most important about this talk. We're going to go over some technical goals we have for an account implementation in OpenZeppelin contracts. Then we'll review a couple of security considerations we have to understand to make better accounts. And finally, I will guide you through a quick way of how to build an account using OpenZeppelin contracts. I'll let you know, but like all of this code is already on alpha, so we will be releasing over the following weeks. Okay, let's start with some background. The first thing you need to know is that we recently received a grant from the Ethereum Foundation to work on account abstraction, right? So this means that we are going to make a library that is consumable for you developers, so you can use OpenZeppelin contracts the same way you have been doing it before. And in this way, you will have available like a couple of variants for making accounts, extending accounts, and also having some primitives that you can use on your own accounts if you want, right? Given this context, we started doing some research, and what we found out is that there is, number one, already a wide range of implementations, right? Like we already know a couple of implementations out there, some quite popular like Alchemy, Safe, Biconomy, and some others, right? So basically, like all of these development that has already been made, like we don't want to compete with that, but we would like to provide a way to also like create new accounts, innovate on top of these ones, and also providing primitives to also enable developers to build on top of those. Second thing is that there are a couple of emerging security challenges that have come up because of the explosion of creation of accounts. So we want to address those as well and having a clear framework for you to move forward when you're building an account. The next thing is that there is a lack of a straightforward approach when you are trying to build your own account. You basically have to research a lot of different implementations if each one has different modules or approaches to bring your own functionality. So the idea is that you should be able to have more expressivity on the way to design on an account, and also you should have like a straightforward path, right? Like the same way you use import ERC-20 and literally you just deploy it, there should be something similar to that, right? So, okay, our observations of this sort of research is that we would like to divide or layer the account implementation into like different layers. The first one should be like a base layer for ERC-4337. The thing with ERC-4337 is that it only defines like a very simple and what do you call it, like, yeah, simple interface, right, and a set of rules. But on the implementation, things can get very different. So we would like to have like a base layer for ERC-4337 account that is super solid, battle tested as everything in OpenZeppelin contracts is. Then from there, we go to the validation layer, which means this is like the place where you put the logic to validate a transaction, right? If you are using a regular EOA to sign a transaction and putting it into an account, this is where the logic for validating the signature should go. We think this thin layer should be also kind of customizable, and you guys should be able to bring your own functionality at this layer, right? Although there is another layer, which is the modularity layer right here, in which there are a couple of competing EIPs or standards. We think there is a lot of innovation coming on here and also happening right now here. So yeah, we want to provide you like a way of using either a custom validation mechanism on the previous layer and also like a modularity approach if you want to. Finally, the idea is that we have, or we end up having a similar to a wizard-like experience. Who has used wizard, like OpenZeppelin wizard from here? All right, so for those who don't have context, OpenZeppelin wizard is like our tool to build smart contracts in an opinionated way. So you can go to wizard.openzeppelin.com and you will see what I'm talking about. So basically, we would like you to come to Wizard, create your own account, just select a couple of options, and you're ready to go. All right. Talking about mass adoption, I think we have been very hyped about the fact that account abstraction is bringing a lot of opportunities to bring new people, but there are a couple of challenges we need to address first. So we'll eventually get there, but there are a couple things to do. In order to understand what we need to do, there are a couple of related ERCs and best practices you need to understand and follow. The first one, of course, is ERC-4337. I mean, is the base ERC, and it has a couple of rules that are quite interesting. You know, all that is related to paymasters, aggregators, all of that is quite complex. We'll eventually get there too, but for now we want to focus on the account side of 4337. Then the second ERC to take into consideration is ERC-7562, which corresponds to the validation, storage validation, well, not storage, there are a couple of validation rules for 4337, but the main or the most important ones, in my opinion, are the storage validation rules. Why is this important? Because there are some, what you call it, like setups in which you can create an account, and basically you are violating some storage rules, some storage validation rules. Why is this important? Because otherwise you wouldn't be able to use the decentralized peer-to-peer network to process user operations. You can still use a private bundler, that would be fine, but ideally we would like to have an implementation that works out of the box with the decentralized network. And finally, ERC-7739, this is a thing we stumbled upon when we were implementing the account. Because basically, there are a couple of issues with replayability if two accounts are owned by the same key. I'll get into that. But this is a cool ERC to get to know more about like how to bind a signature to a specific account implementation, which is pretty important to avoid replayability. All right, so let's get into how to do account abstraction, just for a quick reminder. Remember that a smart account is way more than just the validation mechanism, right? You can add modules, you can have like custom logic, all of that. But ideally, you will focus only on the validation logic if you are building your own account from scratch. From this, we have seen a couple of amazing innovations like CK email, which is using your email to send a transaction from a smart account. This is pretty clever. Also, CK identity, we have seen a couple of options like using passports and these kind of things. So this is why we think the validation logic layer is like an important part that should be extensible for developers, because a lot of innovation is happening right here, but it's being brought up as modules, which is also a valid approach. All right, so ideally this is what you should do if you're using OpenZeppelin contracts. This is not public yet, we're still working on that, but this is like what we are trying to achieve. As you can see, it's only importing an account ECDSA, in this case, this is controlled by an EOA. And there are a couple of things to note here. Let's get into that. So number one, is this upgradable? Not really. The thing is that in order to create an account, you probably will need a factory, right? And if you need a factory, you basically need some way of initializing the account. So upgradable contracts are perfect for initializing, right? They are basically designed for that. And it doesn't mean that the account is upgradable, it just means that it's a clone that you deployed and then you initialized. Second thing is, it is a draft. Well, yes, some of these ERCs are still a draft, so we have a couple of challenges there, because we guarantee backwards compatibility for all of you, so you don't have to manage or deal with that. So based on this, we wanted to, we want to provide you with an implementation, but make it clear that it is still a draft. A couple of things may change, and of course we will keep working on this, and we appreciate the feedback. Next thing is it clonable? Yes, because as I mentioned, you need a factory, and because of this, you basically need some way of cloning an account so that it is pretty cheap to just create and generate new instances of accounts, right? Okay, so let's get into custom identities or custom signature algorithms, which is the main thing we want to discuss here. So to get into this, let's explore a little bit on digital signatures, right? Right now, the majority of implementations of account already use some sort of validation mechanism, or they accept something like ERC-4337, which is for smart contract signature validation. So in this case, then the most naive approach to bring your own cryptographic identity to a smart account is just use an interface like 1271, include the validation algorithm, and then you're ready to go. But in reality, digital signatures are more than that, and we have seen that, for example, a couple of traditional public key infrastructures, like in governments, corporations, banks, and these kind of environments, these are already widely used. It's just that it's not used in the context of a smart account. So this is why it is important to bring your own cryptographic primitive, because it makes it easier for players in the industry, let's say traditional finance, to just come here, use the same key they were probably using for authorizing transactions within their organization, and they should be ready to go. So they are widely adopted as well. And battle tested, I'm adding a quote here because, well, it's not the same environment. They have been around for years, but like in closed environments, it's different to these, to the crypto industry where everything is open source, is pre-battle tested. So yeah, I think this is a cool, it's a cool experiment, but definitely we need to see how it behaves over time. All right. Particularly with this thing, the wide adoption of some digital signature schemes regularly means that it's cool for regulation, right? There is some sort of regulation around like traditional finance using access control mechanisms, so we can also leverage that for real use cases. Right now in OpenZeppelin Contracts for signatures, we already have 3 different signature algorithms available. The first one is the good old ECDSA, right? The one that is controlled by an EOA. This is already there and has been there for a couple of years. We recently implemented a P256 implementation. This is in Solidity. And the reason why we did it is because we identified that some chains, particularly some L2s, may not have already enabled EIP-7212, which is the one that validates these kind of signatures. So because of that, we came up with an implementation that we think is efficient enough and is well designed for you to use it. But also, if it detects that the precompile is available, it will fall back to this precompile. So you can use it out of the box, removing all of the considerations that you should have as a developer. You use import it and use it as everything in OpenZeppelin Contracts. Also, we are adding our RSA library. This is because we have found a couple of government public infrastructures that depend on this particular algorithm. So it is there for consumption. Also, it's pretty popular in some use cases, like, for example, DNSSEC. ENS, probably you have your ENS, but ENS depends on this algorithm for some DNS providers. So it's also a good primitive to have. We already have it in OpenZeppelin Contracts. All right, let's like recap a little bit on what a digital signature means, just for you to understand a couple of issues that are coming. So basically, a cryptographic signature is just a message that you hash. You generate like some piece of data, bytes 32, and then you use a private key with a signature algorithm to produce a signature, right? Eventually, then you will use a public key and your signature with the same digest to pass it through a verification algorithm, and it will return true or false depending on whether it was successful or not. So the thing with this is that we can find out that there are 2 main algorithms in this. Number 1, there is a hashing algorithm, and number 2, there is a signature algorithm, right? So this is important because you as developers, you probably will be constrained by whatever is an off-chain, is off-chain signer, right? Usually people already have like a device, a YubiKey, some sort of software that doesn't depend on you, and is probably using one of these custom hashing algorithms. We're pretty used to use Keccak 256, but in reality, some signers, like off-chain signers, for example, the one you have on your iPhone, the secure enclave, will try to use SHA-256, right? So this is not really a problem, like we can just rehash it, but we think this is too opinionated, and this is the sort of thing that we would like to have more contribution and opinions from you. This is basically the idea, because some of the off-chain signers are constrained to specific algorithms. Like, we need to work around this, right? And this will happen depending on how you compose your accounts. It's probably becoming a mess if we don't take care of like standardizing this or something similar. So another thing to take into consideration is replayability across same key accounts. This is, let's say you have account A, account B, and both are controlled by the same key. Well, then there is the possibility in which if you sign a transaction to send, let's say, 1 Ether to Vitalik on one account, that same signature can be used on your other account to transfer 1 ETH again to Vitalik, right? This is not ideal. This is an issue that was originally discovered by Curious Apple. There is a good write-up on the internet that you can also search. Just look for replayability on smart accounts. You will find it. So the idea to solve this is that we need some way of binding the signature to the current domain in which it is used, right? So this is perfect to do, EIP 712 is perfect for doing this. Are you familiar with EIP 712? Okay, I see a couple of hands. For those who don't have any context, EIP 712 is a way of constructing signatures with types. Basically, you can sign a message that has an uint256 type and a couple of others. It's like a struct you can sign. And what is special about this struct is that it also includes the address of the current contract and also the chain ID, which makes it, you cannot reply a signature because it is bound to the current implementation that you're signing the message for, right? This is actually what ERC-7739 is proposing. It's like a way of rehashing a hash so that it adds some context for you to understand better what is going on instead of just signing an opaque signature, an opaque hash, sorry. So, all right. Next thing is, another thing to consider is that what if we want accounts to be owned by accounts? So in theory, this is possible. Like we have seen multi-signatory schemes in which you have a single account owned by multiple accounts. But in this case, if a smart account wants to own another smart account, it comes with a lot of gotchas. The first thing is like, okay, if B is owner of A, what should B sign? Like, should they just sign a message that is for the domain of B? Or should it sign a message for the domain of A? What if there is another domain? Like probably you're signing from B to authorize on A an interaction with an application C, right? So it's starting to become a mess in this way, and it's becoming opaque for whoever is signing this on their user side, okay? Second issue, like how should we validate from A that the signature is correct from B, right? Because this has to do with storage validation rules in 4337. So yeah, like for example, if in the validation phase, which is literally where you check signatures, if you go to another contract and check storage, let's say to record the public key, then you are violating some of these rules, right? So these are some of the challenges that come in when you want to like add composability to accounts. We have found this as an issue, and we of course want to work like to solve this. Just a quick quote. This is a this is a popular joke in computer science. There are 3, not really 4 things in computer science, and one of these is signatures in account abstraction wallets, right? But yeah, this is why we want your collaboration, and this is how we're doing it. Basically, we have 3 main goals with our implementation. We want it to be secure, we want it to be layered, and we also wanted to make it extensible, right? We don't want you guys to start OpenZeppelin contracts and then become vendor locked in to whatever we have. Basically, the idea is that you can take any of the components and use it for your own implementation so that we can foster a better innovation space and also a more expressive, way of creating accounts. For this, there are a couple of security considerations, like, for example, we want some audited building blocks for you to be safe whenever you're building your account. Also, we want to have a strong cryptography primitives. These have been audited by the research team at OpenZeppelin, so shout out to them. They have been doing an amazing job. Number 3, replayability issues, as I mentioned. Number 4, we would like to maintain user operation readability. We don't want the user to end up signing something they don't understand because this is super dangerous. And number 5, we want it to be community-driven, which means we really want your feedback on this and try to co-own the development with the community. So this is how we build an account. This is ideally the sort of steps you should follow. So number one, you pick a base account, starting from account base, which has a virtual function for validation, right? Then you add your 7739 signer, and from this you get immediate replayability protection. Then you just have to fill both virtual functions that are there. One of these is the validate signature using ECDSA recover, and you don't have to worry, this already has the replayability protection in place. So whatever you receive as a hash is already bounded to the account. Number 4, use deploy, and that's it. Thank you so much. Is there any question?
Thank you, thank you. So now we're going to the Q&A section. For those who want to ask any questions, we have this QR code on the left. Scan it, add your question, and upvote questions that are very interesting. Thank you, Ernesto, for the talk. Now we're going to ask, I think we're going to start with the popular questions. So the first one is, why not incorporate all or as many popular algorithms so as to apply to as many external opinions and implementations?
Right, this is a great question. The honest answer is that it is really difficult to implement cryptographic schemes, especially in Solidity. It comes with a couple of challenges, so it's a tiring process, right? We're open to receive contributions on that. It's just that it is exhaustive, it takes time, and we also have to audit those. Also, I forgot, but at the end of the presentation, there was a QR code for the community repository. Everything that you want to add, like on the community side, is welcome on that repository. We have less, we have more relaxed policies on that repository, so everything is welcome from your side.
Fantastic, thank you very much. Now for the next question is, would you be able to implement your own custom functions such as 2FA or social recovery?
Yeah, the short answer is yes. The long answer is that we would like to understand exactly what it means to have 2FA, right? Because what if we want to be compatible with like regular Web 2 workflows, or do we want something completely new that is EIP 712 based, right? These kind of things are like worth discussing, but we eventually will get there.
Fantastic. How can we solve fragmentation problem in ERC-4337?
Good question. I would say having like a sort of, what do you call, like a straightforward framework, like a set of steps that are pretty clear enough to everyone, we'll probably sort of solve it, but in reality, we already have implementations. So I guess we have to work out and, work around them, which is like the usual, what do you call, like it's the way things work, right? We just like continue building on top of what is going on.
Gotcha, yeah. Okay, so for the next question, there are a few conflicting EIPs for plugins and modules. Will OpenZeppelin take an opinion on these, or will leave that up to the implementations?
Also, really good question. We would like to have an opinion because we don't, usually we try not to provide you with 2 versions of the same thing, right? But like we definitely need to experiment with these modular standards to understand for which cases are better. So probably our opinion will end up looking something like, okay, for these use cases, you should use this ERC, and for this other, you should use this other. But again, we are implementing this on the community repo of OpenZeppelin Contracts, so basically all of the ERCs that are for modularity are very welcome to be implemented from contributions from you.
Okay, and we have one more question. If you want to ask more, feel free to do it. Is it possible to create smart accounts that work with iPhone security enclave? So I guess with a different signature.
Yes, 100%. The P256 algorithm that we just implemented is the one that is used by the secure enclave. So yeah, you just need to create your account. Make sure that you can select, well, make sure that you're using the same hashing algorithm as in the enclave. This is just pretty easy. You just grab the message or the hash in another hash, and that's it. But yeah, the answer is yes.
Nice. And I think I have one question from me. What's your favorite thing about account abstraction? What you're trying to solve overall for the general users?
Yeah, I think I'm excited about users bringing, like, usually users already have some way of authentication that they are familiar with. And I think I'm pretty excited of seeing all of these people bringing these into their own accounts so we can onboard people more easy.
Fantastic. Ernesto, thank you again for the wonderful presentation on smart accounts and account abstraction. Please give him a round of applause. Thank you very much.